Welcome back and thank you for keeping it NTV. You're still watching NTV Weekend Edition. On Talk of the Nation tonight, we look at the science of DNA. And with the start of the school year, many parents rush to clinics to check for the DNA of the children under their care. But we shall be getting to that a bit later on. For now, we want to understand how DNA science is being harnessed for science. And to help us appreciate this, we have Professor Segun Fatumo, the head of the NCDs Genomics at the Medical Research Council, Uganda. Good evening, Professor, and thank you for joining us.
Good evening.
Next week, you will be hosting the 15th African Society of Human Genetics Conference. Talk to us about the training of genetic sciences and how has it been embraced in Uganda to a point that we now have some experts in this field?
Yes, we do. We're just starting in Africa. So genetics have been around for a long time. Maybe I'll start with trying to give an understanding of what that means. So DNA is like the instruction book of life. So that's able to tell us what your eyes should do, or what your liver should do, or what your kidney should do. That is DNA. So when you put that together, so a gene, for example, is like a recipe that can give you what the eyes, or the color of the eyes, or the function in the liver or in the kidney. And what we're doing next week, we're going to be having a conference where we have experts coming from all over the world. We have people coming from all over Africa, in the US and Europe, brainstorming about how to advance genomics in Africa, how to use artificial intelligence and data science in Africa. So here in Uganda, we've done some training on genomics and genetics and bioinformatics. We just recently, about a week ago, we have some students that had their PhD in bioinformatics at Makari University.
And so, by the sound of what you're saying, this is a new sort of thing that is happening in Uganda?
Yes, it is new. Genomics, generally, the training is brand new because it requires a lot of resources, a lot of high-performing computing, which are already, some of them are already available here in the country, but there's much more that needs to be done.
And what is that needs to be done, given the complexities that come with it, say very costly, like you say, it requires a lot of equipment and all this stuff?
So we need to build capacity. Do training, and that's part of the reason why we are gathering for the conference next week. There have been a training on Master of Bioinformatics at the university. Some students have been trained, but we need to do that at much more larger scale. So capacity building is very important, but we're not at the level where, not that nothing has been done yet, but we're not at the level if you compare to the continent like Europe or in the US. And this is very, very important.
Okay, so why would a layman be interested or in genomics? Is it something that is important to me and the person watching us out there? Yes, it is important to you, to me, and to everybody. And the reason is because we are now in the era of what is called precision medicine. So if you go to your medical doctor in the hospital, if you have diabetes, it is most likely that you'll be given a treatment that another person will be given, another person will be given. So we are now in an era where precision medicine is very important, that people are giving treatment or medication according to their genetics, according to their lifestyle, according to things that pertain to them. As opposed to giving them generally, I'm suffering from malaria, so take Cotem or something. So what happens is, if you have a standard approach where you give a treatment to everybody, what happens most of the time is that treatment is not effective for more than half of the people, and only half benefit from it. But precision medicine is a way where the treatment that is given to you has taken into consideration many factors about you. Okay, so then what is that looking to address? So that's looking to address genomics is very important. Our gene is very important. So if you have, let's say, diabetes, or you have a kidney function, you have a treatment that can help you for whatever disease that you have. And that's very important, so that we don't just waste resources and waste money for treatment that is not effective. Okay, so now let us talk about something that I had highlighted earlier, that is DNA testing. Okay. And here in Uganda, it is now that the school term is going to start on Monday. Many parents, are in the rush to know whether the kids they are going to spend millions on are actually their children, and that is when they'll subject them to DNA testing. Okay. What is your take on that?
So that's very interesting. So DNA testing is a process where you are trying to understand whether the child is your child. I think that is interesting, but my personal view is that fatherhood is much more than biology. So if you have a child, you train the child, whether the child carry your gene or they don't carry your gene, you are their father. They see you as a father. So if you do tests today on that child and the child is not yours, so do you know whether your father is your biological father or your grandfather is that your father has already trained you, has already invested in you. They didn't find out whether they're your father. So I think that fatherhood is much more than biology. If you're the father, you're the father. Take care of the child.
And have you had such cases come to the facilities that are under your care? Perhaps somebody who is having doubts about their child not being theirs.
Yes. So particularly, we don't do that. We don't do paternity tests.
But you do the training.
So we do training on genetics. Our focus is that gene is very important for our health. So for example, if somebody has breast cancer, if there's breast cancer in the family, it's good that you know that there's a gene that could be responsible for breast cancer. So if you know that, it will also help your sister or to help other people in your family. So that is very important to check that. But not for paternity tests, because it's much more complex. Okay. And fatherhood is much more than biology.
Okay, yeah. So what else do you look at when it comes to the genomics? Apart from diagnosis, what else do you do?
Yeah, so many things, we do many things. So now we know that whether you are white or black, whether you are people in a European country or anywhere, they originate from Africa. So Africa there's something that is called the Art of African theory. So everybody that we ever know, so they carry some gene from Africa. So we know that. So genetics help us to understand evolution. So help us understand the medical reason and many other things that are very important.
When you talk of evolution, are we also looking at the evolution of man?
No, that's not where I'm going. I'm going to people understand where they come from. Yeah, so their origin, where they come from.
To trace their roots.
Yes, so their roots, everybody's root is in Africa. So whether you are white or you are European, everybody's root is from Africa. Yeah, so that's very important. Yeah.
Have you helped there are some people that you have helped trace their roots when it comes to what you do?
Okay, so yes, there are now some tests where people can check their roots. I've seen many people in the US that now say that, oh, my origin, maybe I have 50% of my gene is from Nigeria, or it's from Ghana, or it's from Uganda. You see people like that want to find out their roots. And that is very important to them if they want to. But not particularly trying to look for whether somebody is your biological father or not. Yes.
Okay, and so you did mention that there is a use of artificial intelligence and data science in revolutionizing disease prediction and drug recovery, and also the whole concept of genomics.
Yes.
How is this being advanced in the country?
So currently we're not at the elementary level. Not only in Uganda, in Africa. So the conference we are doing is an international conference. So we have people coming from all over the world for this conference to discuss how we can advance genomics, how we can use this as a tool that can make us to also catch up with other continents like European continents and in the US. Yeah.
And so what other activities are going to be happening at the conference? So
we're going to be listening to the best mind ever all over the world, giving talk of what they've done in their own country. We're going to be doing some training. We started the training just today. We have students that came from all over Africa, 15 different African countries. So we're training them on how they can analyze large-scale data sets. So where are those data sets, where are the resources, how they can use a tool like machine learning, tool like artificial intelligence to analyze that. So we do that training today and tomorrow. And we're going to be keeping those students very close and following them up. We're going to be coming back here in June at Makari University. We're doing also a very similar training on a genetic risk score. So these are very important things, and that's why we continue to build capacity and train people.
Okay, yeah. And you did mention that you have already carried out some training in Uganda, that is under Makerere University.
Yes.
And did you get some people that were interested in the course, in studying genetics or genomics?
Yes, many people are interested. I think the problem we have now is that we lack people that are able to train them. There are many people, every day I have students from Uganda that want to learn genomics, that want to learn how to use all these tools, and you can only support a few. So that's why with this conference we are doing, we can have more experts all over the world that can support us. So build more capacity. Like I mentioned to you before now, just a few weeks ago, we have 2 students that finished their PhD in Makerere University. So they are now an expert in their own field, and they will also help to train other people. So the more we train people that advance their career, they will also be able to help us to train other people.
And so looking at the bigger picture, how is this science going to impact disease prevention, diagnosis and treatment in African populations, given the fact that it is not something that we have been used to? Because you said when this genomics is going to look at giving me a drug that I need based on my genetics.
Yes, so that's where we are going. So giving you drug that you need, not only drug, give you the treatment that you need. It's much more than drug. Focusing on you and the disease that you have and managing that, and not putting you in the same box with every other person. It could also mean that there are some ethnic groups that are very related genetically. So how do you support that people? So it could also mean that there's a population of people that have, say, sickle cell disease. So if those people that have sickle cell disease, if they have diabetes, how should you treat them? Should you be treating them the way you treat people that don't have sickle cell disease? So these are what is called precision medicine. So that's the point where we are going to. And one of the tools we're going to be using for that will be artificial intelligence.
Does that mean that the way malaria affects me is not the same it is going to affect you?
It is not. And the same thing also, somebody like me, for example, I don't have malaria. And one of the reasons why I don't have malaria is because I'm AS, so I don't have malaria. It's the same thing also during COVID. When you test me for COVID, even though I had all the symptoms, my test was coming out as negative. The same thing also for Ebola. It means that there are some people that will probably be exposed to Ebola, and the symptoms that they will have will not be as severe as other people. So genetics play a role in that. And
so do we have all these medicines that treat particular genetics types of diseases? That's
what we are going to. That's where I'm talking about precision medicine, where we can have a treatment that focus on that is precise. Okay. We can get to precision medicine.
Okay. All right. As we get to wrap up this conversation, what would be your closing remarks, Professor?
So my closing remark would be that we're in an era of artificial intelligence, and the government should focus now on capacity building and training more people so that Africa is not left behind.
Okay. Yeah. All right. Thank you so much, Professor, for sharing. We are now a knowledge wiser, getting to understand about the genomics and the genetics. And that conversation takes us in for a short break. When we return, we'll be hearing from the world of sport.